Vivian Shwaikani. I'll be explaining today the part 3 of chapter 9, alcohols. In this part, we have many objectives to be covered. We will talk about at each slide. First, let's recall that the general formula of immunoalcohol is ROH or CnH2n plus 1OH or CnH2n plus 2O. And we know that the functional group of alcohol is hydroxyl group OH. And we know that alcohols are classified in 3 classes. So alcohol can be primary, such as this molecule. You have to check here, you have to look at this carbon that holds the hydroxyl group OH. As you can see, this carbon is attached to one alkyl group, so the alcohol is primary. Also, an alcohol can be secondary, like this. Look at the carbon to which OH is attached. This carbon is attached to one alkyl group here and to another alkyl group here, so to 2 alkyl groups, so it's secondary. Or it can be tertiary. This carbon attached to OH is also attached to 3 alkyl groups, which are CH3 in this case. Now, the first objective of our lesson today is the complete combustion of alcohols. As all organic compounds, alcohols undergo complete combustion to form carbon dioxide and water. This is why alcohol can be used as fuel sometimes. As example, consider ethanol that can react with oxygen, producing, as we said, carbon dioxide and water. And this is the balanced equation of the reaction. Here is ethanol, here is oxygen, and it's balanced, as we said, carbon dioxide and water. Now, to be noticed that here we used the molecular formula of alcohol, but for later, we have to use the condensed structural formula for organic compound in all chemical reaction. Now here is an application. I will give you the time to solve it, to do a pause and to solve it, where you have to write the equation of complete combustion of a propanol using condensed structural formula. Here is the solution. Now let's move to our second objective, which is about mild oxidation of alcohols. What is mild oxidation? This is the definition. Mild oxidation is the oxidation that doesn't break down the carbon chain. This implies that only the functional group, which is hydroxyl in the case of alcohol, is concerned in this oxidation. Now, to be noticed that primary and secondary alcohols only undergo mild oxidation, but tertiary alcohols do not. What are the products of mild oxidation? Look. Here is a primary alcohol. As you can see, this carbon is attached to only one alkyl group. Upon a mild oxidation, this is the symbol of mild oxidation, a primary alcohol give this compound, which is an aldehyde, because look at the functional group, the carbonyl group, and here we have H, an aldehyde. Now, the mild oxidation can continue in this case, and this is what we call continuous oxidation. So the aldehyde will be transformed into a carboxylic acid. As you can see, here it is C, double bond OOH. This is carboxyl group of carboxylic acid. Now, as I said, continuous mild oxidation can occur when we have excess in oxidant. We have to see it later. Here is a secondary alcohol. As you can notice, this carbon attached to OH has 2 alkyl group. Upon mild oxidation, a secondary alcohol give a ketone. Here is the carbon atom, and here is the carbonyl group of ketone. And upon continuous oxidation, no reaction is occur. So I repeat, as you can see here in mild oxidation, either for a primary or for secondary alcohol, the alkyl group that was here in alcohol stay the same, and this is why we said that it's a mild oxidation. Only the oxidation concerned the functional group that it changes. The same is here. Now for a tertiary alcohol, as we said, this is an example of a tertiary alcohol. Upon mild oxidation, no reaction will occur. Now, how mild oxidation occurs of alcohol? It occurs because alcohols are considered as reductants. Reductants, it means reducing agents. They undergo mild oxidation by 3 different methods. The first method consists of using strong oxidant, such as dichromate Cr2O7 2- and permanganate. This reaction is a typical redox reaction. There are 2 other methods. The first one, or is to the catalytic oxidation, it will be studied in the next part of the lesson. and the catalytic dehydrogenation in the absence of oxygen. Also, these two will be studied in the next video. In this video, we have to focus on the oxidation of alcohol with strong oxidant. So, this reaction, as we said, is a typical redox reaction where two redox couples are involved. How to balance the equation of redox reaction? Actually, we reviewed this, that is taken in grade 11. We review it in kinetic part. Now, I will ask you to pause the video and to read those steps. And if you don't understand exactly those steps, what is important is not to memorize them, but to apply them as in the next example, Let's take an example to know how to balance this equation. Look, these are the reduction half equation. This is the first one. It is Cr2O7 2- dichromate, and here is Cr3+, and here is permanganate MnO4- that will be transformed into Mn2+. As you can see, let's balance this half equation. Here is Cr2O7 2-, and here I have one Cr3. So first of all, and here I have MnO4- and Mn2+. First of all, I will multiply here by 2 because I have here 2 Cr. Okay? Then I have here 7 oxygen and here nothing. What do we have to do? We have to add as much as water molecules as much as we have oxygen here. So 7 H2O. Now I have here H2, so we will add to this part of the equation 14 H+ that are here. The single thing that stays is to balance what? The charges between both sides of the equation. So we will have 6 electrons here, and thus the charge here will be equal to the charge here. Let's move now to balance MnO4-. As we can see here, I have 4 oxygen, so I will add 4 H2O to this side, then about H+, because I have here 4 times 2, it means 8 H+, I will add them here. And then I will add 5 electrons, as we said, to balance the charge in this side of the equation and in this side. To notice that here is Cr2O7, it's an ion having orange yellow color, and here is Cr3+, that is green, while MnO4- is violet and Mn2+ is almost colorless. Let's consider the mild oxidation of the primary alcohol using a strong oxidant. I repeat, a primary. As we said, it's a typical redox reaction. So we have to follow the gamma rule. Look here, MnO4- is the strongest oxidizing agent that reacts with the most reducing agent, which is the primary alcohol, to obtain aldehyde and Mn2+. What about the equations? Here is the oxidation half reaction. Here is the primary alcohol that it transforms here to an aldehyde. And as I said, for organic compound, we have to write the condensed structural formula always in chemical reactions. So here is, we apply the rules of balancing chemical equation to add here 2 H+ and here 2 electrons. Now, here is MnO4-. It is copied as is from the previous slide because we explained how to balance this half reaction. Here, look, we have 2 electrons and here 5 electrons. So we have to multiply here by 5 and here by 2. And here is the overall reaction obtained. So as I said, we had a primary alcohol that gives what? An aldehyde. Again, with the mild oxidation of the primary alcohol. Now we have to study this oxidation, but using this ion, the Cr2O7 2-. Again, we have to apply gamma rule, but in this case, we will not obtain an aldehyde automatically, or not automatically, we have to obtain, after all, carboxylic acid. This is what we call continuous mild oxidation. So all product will be carboxylic acid. Why? Because we used an excess of oxidant. Okay? Oxidation half reaction. Here is our alcohol, our primary alcohol, and this is the carboxylic acid. So as you can notice in the previous slide, we wrote the primary alcohol that will give aldehyde. Here actually we can write aldehyde that will give me also carboxylic acid, or we can do as I'm doing now, directly a primary alcohol will give a carboxylic acid. All these are typical redox reaction. According to the couples given, you can write them by applying what do you know about the balancing of redox chemical reaction. So in this case, I repeat, it is a continuous mild oxidation. So a primary alcohol will give me a carboxylic acid, and here is the way of balancing the half equation. Now with Cr2O7 2- as explained also previously in this video, this is the balanced equation. Here I have, look, 4 electrons and here 6 electrons. To balance those, the number of electrons lost and gains has to be equal. We will multiply this equation by 3 and this by 2. So the overall reaction will be the following. Now, let's move to study an example about mild oxidation of a secondary alcohol using a strong oxidant. Look, here is a secondary alcohol. As you can notice, I have 2 alkyl groups attached to this carbon to which OH is attached. We said that a secondary alcohol will give us what? A ketone. Can you see here the C double bond O? It's a ketone. To balance it, I have to add 2H+. Why? Because look, I have here in the alcohol 2 hydrogen. Okay, so I will write them here in this form, 2H+, and to balance the charge, I will add 2 electrons. Now, the reduction half reaction, it is copied as is used here, using here MnO4-. So as you can notice, here I have 2 electrons and here 5 electrons. Definitely we will multiply here by 5 and here by 2 to obtain the overall equation. And as I said, here is the secondary alcohol that will give me ketone. Again, pay attention in those kind or in any kind actually, unless for combustion, in all kind of mild oxidation or in reactions in organic chemistry, you have to represent the organic compounds using the condensed structural formula. Here is an example. Okay, here is an alcohol that is secondary. Upon mild oxidation, it will give me a ketone, and here is how is it balanced. Here about the reduction half reaction, and the overall equation will be the following. Okay, here for example, they use the structural formula. We prefer usually to use the condensed structural formula. Now here is an application about mild oxidation of alcohol. Do a pause for the video and solve the following 2 parts. Here is the solution. Look, here this is the alcohol. Just one remark about the way it is written. This 2 means that this CH3 is attached to this carbon. So we can erase this 2 and we can write 2 methyl group attached to this carbon, and this is the solution. Now, about the change in color, we mentioned it, but again, we have to repeat it because it's important and it has to be memorized. Here is a tube containing potassium dichromate. If potassium dichromate is added with primary alcohol or secondary alcohol, there is a reaction that occurs, producing what? Producing Cr3+. So this one is a yellow-orange color. It has the dichromate ion. The color will change to be green. If the color change, we said that the test is positive. It means there was a reaction here between the alcohol, whether it's a primary or secondary, with the dichromate. Now, this is potassium dichromate having this color that is orange-yellow. With the tertiary alcohol, as you can notice, I will not obtain Cr3+, I will obtain again Cr2O7, so no reaction, and the color doesn't change, indicating that the test is negative. Again, regarding permanganate, which is MnO4-, is a violet ion. When added to primary or to secondary alcohol, the purple or the violet color of MnO4- will change, because MnO4- becomes what? Becomes Mn2+. So, and a colorless solution will be obtained, indicating that the test is positive. While potassium permanganate, that is violet, in the presence of tertiary alcohol doesn't undergo mild oxidation, so no change in color. The purple or the violet color stays the same, and no reaction will occur. As a summary for our lesson, alcohols undergo combustion, as we said, to produce carbon dioxide and water. Alcohol undergo mild oxidation. Pay attention to the definition, which doesn't break down the carbonate chain. The product of mild oxidation depends on the class of alcohol, where primary alcohol can give aldehyde and then carboxylic acid, or directly carboxylic acid in the case of a continuous oxidation. Secondary alcohol give ketones and there is no continuous oxidation. Tertiary alcohol has no reaction. And here is the color of permanganate, that is purple, and Mn2 plus, that is colorless, the dichromate, that is orange yellow, and the Cr3 plus is green. Again, here is your agenda. You have to do a pause to know what you have to do in this video. I will thank you for your attention, and I will see you in the next